Death vesicles. Yep, you heard that right. Death vesicles. Welcome back to another episode of Short Stories of Bacteria, guys. Hey everyone, welcome back to another episode of Short Stories of Bacteria. I, as always, am your host, Dr. K, and I'm here to guide you through yet another story outlining the lives of the tiny and infamous, that would be, of course, the incredible, the amazing, the fascinating bacteria. We are just getting back from our Easter break. Hope you guys all had a wondrous and blessed and amazing Easter. And I also hope you are excited about the new story we have about death vesicles. What on earth is a death vesicle, Dr. K, you ask? Well, before we jump into that, real quick, don't forget to hit that like, share, subscribe button if you are on the YouTubes. Or if you are listening to this podcast, don't forget to hit that follow button, whether you're listening on Spotify or on Apple Podcasts or wherever it is that you're listening to the stuff. Anyway, that's enough of that. Let's jump into the scientific side of things. So in order to talk about death vesicles, what a death vesicle is, we need to spend a little time talking about bacteria and when they kind of run amok, right? So bacteria, as we have been talking about on this podcast and now on the YouTube channel for a bit yet, bacteria are super, super useful. We use them for tons of different things, whether they be in our food or whether they be in our own bodies. They're super, super useful. Someone, a friend of mine once, I guess maybe hyperbolically said that something to the tune of all the cool things that humans do, it's just us using bacteria to do those cool things. The bacteria are the only things that are actually doing the cool stuff. Again, that might be hyperbolic, but the point remains that we use bacteria for a whole bunch of different things. They're super, super useful, and we need them in order to survive. That being said, we are all very aware, right, that sometimes bacteria can run amok. They can sometimes wreak havoc on us, and we have to instead figure out ways to control them when they're trying to cause disease or trying to destroy parts of human infrastructure or whatever the case may be. So while bacteria are useful, point number one, while bacteria are super useful, sometimes we need to be able to control them or kill them. Now, this shows up a little bit within the context of what's known as a biofilm. So what is a biofilm? So a biofilm, you can kind of think about it as just a group of bacteria, a group of stationary bacteria that are locked into one spot and then just growing, right? So oftentimes it's a complex mixture of different bacteria, although sometimes it can just be one particular bacteria growing in a region, in a localized area. But the main point being is that it's a whole bunch of different bacteria and they lock onto a given location, right? And then they grow and they grow and they grow. They're stationary and they grow. We're going to talk a little bit about how biofilms are regulated, how you turn them on and turn them off and things like this in a little bit. But that's the basics that we're working with. Now, the problem with biofilms, they may sound like a really cool structure, and they actually kind of are, but the problem with biofilms is that if you have a biofilm where it's not supposed to be, right, and you'll see this in things like catheters in the hospital, you'll see this on like ship's hulls, things like this. If you find a biofilm in a location where it's not supposed to be, it's really hard to get rid of them. These biofilms attach really, really tightly to whatever substrate they're holding on to, right? And so the only thing you can really do other than like physically scrape them off, which is not really practical or successful, honestly, is you have to treat them with antibiotics, right? So you have to take a whole bunch of antibiotics that'll kill the bacteria, and you have to drop it on the bacteria and try and kill the bacteria that way. Now, there's a couple different problems here. First of all, there's the issue of antibiotic resistance, right? Eventually, those bacteria are going to become resistant to that antibiotic, and then the antibiotic is useless for that biofilm. And secondly, those antibiotics tend to not really, they don't tend to kill the vast majority of the bacteria in a biofilm, right? With the biofilm, you have, like I mentioned, it's this growing culture, for lack of a better phrase, and there's these layers of bacteria, layers upon layers. And while the antibiotic, when you drop it on there, will peel through the first set of layers, right? Oftentimes, you run into this issue where the antibiotic doesn't get to the core bacteria that are in the center, right? So point number two, even though we can use antibiotics to treat biofilms oftentimes, sometimes these biofilms will not respond to the antibiotics or will become antibiotic resistant. So that's a really big problem. And so what a bunch of researchers are doing nowadays is they're trying to think, okay, how do we go about treating biofilms, especially if they are antibiotic resistant, right? It's an emerging problem. Now, it's a really, really good question, and it's one that a bunch of folks out of Washington State University, Washington State University, they were asking that question, and that's how we end up with this topic of death vesicles. Very exciting stuff. Now, what the people at Washington State were looking at, they were looking at a bacteria called Pseudomonas aeruginosa. It happens to be my favorite bacteria. My favorite bacteria, Pseudomonas aeruginosa. Pseudomonas aeruginosa it's an opportunistic human pathogen. So only in certain contexts will it start to try and kill humans. But if it does, right, they're very, very dangerous. So that's very cool. But these researchers were like, okay, here we go. We have this biofilm made exclusively of Pseudomonas aeruginosa. What are some ways that we can try and kill this biofilm without using an antibiotic? And that brings in this topic of death vesicles. So let's start off with what is a death vesicle? And again, before we actually answer this question, we have to go back to how is it that biofilms are formed? You see, I mentioned a second ago that biofilms, they attach to a little substrate, right? And then they grow from that location. But that doesn't just happen. There's several different stages to the growth of a biofilm, right? So first of all, what's going to happen is a colony is going to attach to a given substrate, right? And then they have to adapt to that particular environment, right? There's going to be different pHs, there's going to be different salt concentrations, it's a different environment. And so that fledgling colony needs to adapt to that given environment, right? Then what's going to happen is once they've attached there, then they grow and grow and grow and grow and grow. And then there's a really important point, right? Once they've grown to a certain concentration, or once they've grown to or if they want to move or something like this, then they have to detach, or at least detach part of that colony and then move that to a new location, right? Then what'll happen, right, is the biofilm that was left there will tend to die off, right? Now, all this to say that there are several different stages of growth when it comes to a biofilm. There's the initial attachment to the substrate. There's the growth of the colony. There's the migration of the colony to a new location, especially if the resources are used up. And then finally, there's the death of the previous colony, right? Now, every single one of okay, so point number 3, there are several different phases, growth phases, that are required in order to have a successful biofilm. Okay. All right. Now, each of those different phases, the attachment, the growth, the migration, and then the death, each of those is very, very tightly regulated, right? You want to make sure that you're turning on your growth genes at just the right time. You don't want to turn on your death genes just as you're starting to grow. You don't want to turn on your growth genes just as you're trying to move, right? This all has to be controlled and regulated in a very, very precise way. And there's a lot of genetic manipulations and transcriptional and translational manipulations that go into that. It's very, very cool stuff. And so what the bacteria need is they have to have some way of communicating with each other, right? To tell each other, okay, now we're in the attachment phase, or now we're in the growth phase, or now we're in the migration phase, or now we're in the death phase, right? They need to have a way of signaling to the rest of the group, right, that they're moving from one phase of growth to the next. Okay? Right. Now, there's a couple different ways they can do that. One of which is with something called extracellular vesicles. Now, a vesicle, you can kind of think about it like a little bubble of fat, right? We typically see them in like high school textbooks or college textbooks. We see them within the context of like, oh, it's a little bubble of fat and it moves protein from the Golgi apparatus to the cell membrane or something like this. That's true. It's really cool. It's typically described in high school as like, that's the highway system of the cell or something like this. But the main point being is that vesicles are these little bubbles of fat and they migrate. It can either be protein content or sugar content or fat content from one location to another. Another thing that they can transmit, right, is instructions essentially. And so one thing the one role that extracellular vesicles has in something like bacteria, especially within the context of biofilms, right, is they can carry instructions to signal Pseudomonas aeruginosa to move from one stage of biofilm growth to the next. Okay, so that's point number 4. It's a big one. One way that bacteria know which phase of biofilm growth to enter into is through the presence of these extracellular vesicles, right? So there's like an extracellular vesicle that says, hey, it's time to attach, right? And then there's an extracellular vesicle that says, hey, it's time to start growing, right? And then there's another one that says, hey, it's time to move. And then there's another one that says, hey, it's time to die. Okay? So very, very cool stuff. Now, what these researchers were doing is they thought to themselves, well, gee, if we have extracellular vesicles, right, that already belong to Pseudomonas aeruginosa, so they're not going to be super suspect of these vesicles. If we have extracellular vesicles that we already know tells Pseudomonas aeruginosa that it's time for this biofilm to die, could you take those vesicles, give them to an existing biofilm that is growing and wreaking havoc in a body or on a ship's hull or whatever the case may be, right? Could you give these so-called death vesicles, and this is what they called them, death vesicles, because they signaled death of the biofilm, right? Could you take those, give them to a healthy colony, and then shut it down that way? That was their game plan. And so what they did is they took a single dose of these death vesicles. And again, these are vesicles that say, hey, it's time for the biofilm to die. They took that dose of death vesicles, gave them to a really healthy biofilm, right, that was starting to grow, gave it to that biofilm, and it brought down that biofilm by almost 100%. 99.9% of the bacteria died, right? They died because they were getting signals that looked familiar, right? That said, hey, it's time for you to die right now, right? It's a wild, wild, wild idea. And it's crazy that it worked super, super well. Essentially, it's a way of taking a language that bacteria use amongst themselves, using that language to tell them, hey, it's time for you to die. And the bacteria, because it looks familiar, it looks like their own language, they respond to that and then will die accordingly. It's a really cool instance. It's a really cool instance of manipulating the language of bacteria. It's a really cool example of how researchers are pushing past antibiotics as a way of regulating the growth of bacteria, especially when they're trying to do damage to humans and things that humans care about. So let's wrap this up. Number one, bacteria can be very hard to deal with, especially when they band together and form something like an antibiotic-resistant biofilm. That's kind of rough. Number two, biofilms are dependent on specific signals that allow them to move through the different phases of biofilm growth. Number three, some of these signals are extracellular vesicles, right? Including both growth vesicles and so-called death vesicles. The growth vesicles signal, hey, it's time to grow, and the death vesicles say, hey, it's time for you to die. Right? And so this batch of researchers, they used these death vesicles as a way of telling the bacteria in a biofilm that it was time to kill themselves. And this way, they got rid of those pesky biofilms once and for all. Very exciting stuff. But anyway, guys, that is all I have for you today. Thank you so much for tuning in for another episode of Short Stories of Bacteria. I guess that's all I have for today. Until next time, I'm Dr. K. I'll see you guys later.
Hey everyone, thanks for watching that video. Hope you guys enjoyed it. If you liked what you saw, don't forget to hit that like, share, subscribe button, and I will hopefully see you guys in the next video. Later!